Pretty quick overview of the Age and Growth Project. And as Gary mentioned, I've listed here all of the people working in the lab. So the primary objective of the Age and Growth Project, and really any Age and Growth lab, is to generate age data from fish samples that are collected, in our case, throughout the Division of Marine Fisheries. All of those ages end up going pretty much directly into stock assessment analyses, which then goes towards management decisions. So some of those things that the ages are used for are estimating growth model parameters, calculating fish mortality, tracking cohorts of fish through time to identify strong and weak year classes. But the secondary, or you can almost think of it as a primary objective, is to maintain a really high quality control to provide the most precise and hopefully the most accurate ages possible for the assessment process. So a little bit of background on how DMF came to have an Age and Growth Lab. First of all, there was a need identified. So prior to the Age and Growth Lab, individual projects were all kind of aging their own species. And this led to a real lack of a standardized quality assurance, quality control. And, you know, we had some projects that were using seasonal technicians and that kind of thing to do some of the aging. So we had rotating staff, which makes it really difficult to assure any sort of precision from year to year or even within year. So Mike Armstrong kind of headed the push to get an Age and Growth Lab. And so he got a grant through the U.S. Fish and Wildlife Sportfish Restoration Program and funded the lab to be built. And that grant funds us every year, our operating budget. And that's all through Wallop Row funds. So it's pretty steady. So in 2009, we were able to build the lab, and given that we had a little bit of money to do it, and we wanted to be kind of on the cutting edge, we decided to build something that wasn't just a closet for people to sit alone in the dark like most Age and Growth labs. So we were fortunate enough to have 2 rooms that were adjoining in the Gloucester office, and we took the wall out between them and got to set up all the cabinetry and everything just the way we wanted it to have an efficient Age and Growth lab, which was really great. So species we work with on a regular basis include the Elzey, so alewife, blueback, American shad. That's sort of our bread and butter. We do the most of those. We do quite a lot of striped bass, fair amount of black sea bass, winter flounder, tautog, bluefish, smelt, scup, fluke. Over the past 5 years, we've averaged about 11,000 fish worth of samples, 11,000 fish worth of ages per year. Mike likes to tell people we do 20,000 a year. And if you include the fact that a lot of the fish we work with we age multiple structures on them, we get closer to that. We're not quite there, but closer. So sample sources, we get our samples from a lot of places. Resource assessment typically gives us a lot of our samples. We get quite a few through port sampling, so commercial striped bass sampling, and a few others. Tagging projects provide quite a few. The anadromous project, you can see Ben there, although he's not holding his typical river herring. They provide us with a ton of samples. And then we've got other smaller mass DMF collections. Our sadcat sampling does a lot of striped bass, but in the past few years, we've expanded that to include black sea bass, scup, and fluke. We've also got freezers out at some fishing locations to collect striped bass racks from both recreational fishermen and a couple of charter boats. And that really helps us do comparisons between otoliths and scales. We get quite a few samples from the ventless lobster trap survey. And then we've got a few special projects here and there, both within and outside of the agency. So a few of our special projects to highlight. This is by no means everything special project related we've done, but we worked quite a bit with Micah Dean, doing some cod stock discrimination, looking at the size of the first annulus between the winter spawning fish and the spring spawning fish. And given that they have different amounts of time to grow before that first annulus was laid down, we were able to discriminate the stocks. And so that's been published. That was pretty interesting. We've done some smaller things like black sea bass, looking at some extra samples from the spawning aggregations. We've been collaborators doing the aging side of things for a couple of SK grants on wolffish and halibut. And we've done quite a bit of work on validation and structure comparison studies. So Elise is just finishing up her master's work, or actually did just finish up her master's work, still working on publishing the black sea bass age validation stuff. But we've also done, we've also have a couple publications out on structure comparisons of American shad and tautog. Tautog, we're still working with ASMFC. We're in the middle of a exchange now to try and get pelvic spines to be an accepted structure. As in our comparison, we found that they are as precise as the other structures we've used for tautog and non-lethal. So that's very helpful. And recently, I just finished up. I was an editor on a giant ASMFC, so Atlantic states and Gulf states aging manual. It includes input from, I don't know, probably 35 or 40 contributors. And it's like a 300-page document. It's a beast. It's been a lot of years in the making, but it's great to finally have that out there now. So enough about what we do, a little bit about how we do it. So as I'm sure all of you know already, fish growth happens at different rates at different times of year. And the hard parts within the fish, so the otoliths, the scales, even bones, will record that growth in different ways. And so you can take a cross section or just the whole otolith and take a look at it, and you can count the rings just like in a tree. You know, bottom left picture here, you can see is just a tree. Bottom right is a wolffish otolith cross section, and they're pretty long lived, but we were able to get accurate, well, hopefully accurate, but precise ages up to fish 33 years old. So our primary aging structures that we use, typically otoliths are our go-to if we can. They yield the most precise and accurate ages. The downside is that it's lethal, so we can't get otoliths from all our fish, all our projects. Sometimes the small size ranges, you can't get the otoliths for various reasons. So we do some work with scales. There's a lot of historical data with scales, which is great for comparisons. It's non-lethal, which is nice, but they can provide imprecise and inaccurate ages in some species. You can see the plot on the right here. It's a bias plot between scale ages and otolith ages for striped bass. And there is some underaging of the scales in sort of across the age range, but it really starts falling apart after about age 10 or 11. So having some otoliths there in the upper size ranges especially helps us make some corrections. So like I said, fin spines we're using for tautog. We're still working with ASMFC to get that as an accepted method for stock assessments. It's great because it's non-lethal, and they can be very precise. And one of the nice things about non-lethal in that species is that we have a large market for live tautog, and we have not been able to sample adequately the age of those. And hopefully now, as that becomes more accepted, we'll be able to get age samples off of market fish. So a little bit about the process and the equipment. Some of the fish we get in come to us as actual fish, not just the aging structures. And so we spent quite a bit of time in the wet lab processing fish. And over the last year and a half or so, we've put quite a bit of effort into making a digital collection system the wet lab. So we've got a computer there that's running a program called FEED, which is short for Fisheries Environment for Electronic Data. It's a program that was made at VIMS, and it works pretty well. We're still working out a couple kinks in it, but it will take data straight in from a digital measuring board and a digital balance, much like they do with Fiscus on resource assessment. And all of that data will go straight into a database, and we've got the label printer, so we can print out labels for our envelopes and all of that stuff. And it really cuts down on transcription errors and that kind of thing. So I will note real quick, I could have put in a little video here of some otolith pulling, but I thought right before lunch you didn't all need to see a graphic videos of fish's head getting cut open. So if you're real curious, you can find there's a couple of them on the DMF YouTube. So like I said, some structures are ready to go right after we pull them out of the fish. So like a low-scene otolith, the river herring, as long as they're clean and dry, we can put them right under the scope and get ages. A lot of fish need further processing. So many of the scales we do need to be cleaned and mounted between slides or pressed into acetate. The old Carver heat press is in the upper right there. So we use that to sandwich some scales between acetate and two metal plates, and you add some heat and pressure, and you get a nice impression of the scale that you can actually see through, which makes it easier than aging a whole scale, especially in those thick species, the species with thick scales like striped bass. A lot of the otoliths and fin spines, we need to cross section and affix to slides before looking at them under the microscope. And some of the otoliths we actually bake before looking at them to increase the contrast, which is, it's very similar to the old crack and burn method with an alcohol flame, but it's a lot easier. So the photo in the lower left there is just the isomet saw that we use for cutting thin sections, and then the muffle furnace in the middle. And then over on the far right, most of our aging is done with image analysis software. We use Image Pro typically, and a computer that's it's got a microscope that's mounted on, or it's got a camera that's mounted to a microscope or just a simple lens tube. And this is really beneficial for us because it allows multiple people to look at the same structure at the same time, which is great for training and for consensus aging and that kind of thing. So just a couple quick examples of what we see. Upper left is a tautog pelvic spine, and you can see those real clear sort of translucent bandings there that are very easy to age, easy to count. Upper right alewife otolith can be a little tricky at first, but with experience, when we're doing 4,000 or 5,000 of them a year, you get pretty good at it. The bottom two pictures are striped bass, both from the same fish. The one on the left is a cross section of an otolith that was baked and thin sectioned, and on the right is a acetate impression of the scale. And I don't know about you, but I like the look of the otolith a lot better than the scales. So all of our structures are aged by two agers. So that's double aging, and everything is done blind. So that's no info about the length of the fish. Typically, we don't have info on the sex. Any info about what the other ager assigned as an age, none of that. So there should be no biases there. Once the two ages are assigned, we sit down and look at them. Any that disagree with each other go through a consensus aging where the two agers sit down together and reach a consensus. Most of the time, that's fairly easy. Every once in a while, you get a fish that you just shake your head at and you toss it out. So then once we have the ages, we calculate coefficient of variation. We check for biases. And then, so that's between readers typically. I go back and I look at the final ages to look for any outliers, just to make sure we don't have any weird data. Sometimes there's a length that gets transposed or something, and it can be pretty obvious in those. But we check the outliers and we look at it within year and between years to make sure there isn't any drift. We also use reference collections. So we have collections of, it depends on the species, but between 200 and 500 samples for a given species that we age a subsample of before we start in for the year to make sure that we don't have any discrepancies from how we've aged them previously. And if we do, then we can work those out before we start aging for the year and have a big problem. We also run frequent checks with other agencies. Every year, their ASMFC holds a quality control meeting that includes states from all along the eastern coast, and we get together and age a set number of samples and compare and make sure there aren't differences between states, which is important as a lot of these ages are going into regional stock assessments instead of just for Massachusetts. And finally, we have good working relationship with New England Fisheries Science Center Aging Lab, and we check in with them on relatively frequently. So once we've produced our ages, we've got all the structure still sitting around. And so we've recently developed an archive out in the Blue Building where everything's being put in these plastic totes to help keep them safe from things like leaky roofs. And all of those samples have been cataloged and organized into these boxes. We've got samples that go back to the 70s. This photo is actually old. We've got about twice as many samples in the archive at this point. And so it's well organized, and I can tell you which box number, if you want striped bass scales from 1982, I can tell you they're in box 35 or whatever. They're all labeled. It's pretty well organized. So in conclusion, the Age and Growth Lab plays an integral part of providing data for fisheries management. Even though we've only been around for about 11 years, we've become one of the leading age and growth labs along the East Coast. And we've frequently provided training and consultations for other agencies and labs and universities. We've kind of spearheaded the river herring otoliths, as a lot of people were using scales before, but it's very imprecise. And so we've trained a few other people on aging those, but I'm constantly getting emails from people asking me my opinion on this structure or that structure, or the best way to do any various aging activities. And finally, Mike keeps saying he's going to throw samples at us until we say uncle, and we haven't yet. So I'm open to the possibilities for new special projects. If anybody's got anything interesting that would be beneficial to the agency, we have open ears. So with that, I'll open it up for questions. Thanks.
Thanks, Scott. Any questions?
Yeah, I've got a question.
Okay.
Who's this?
It's Mike Paul.
Okay.
Hey, Scott.
Hi.
So why are you archiving? Is that to go back and check for data, or is there additional information that could be squeezed out of those age structures?
A little bit of both. There are things that can be interesting about old samples, especially, some of the striped bass samples from way back when, or the scales weren't cleaned before they were put away. So there's actually a fair amount of tissue. So it is possible to go back to some of those old samples and get genetic information. Yep, there you go, Ben. But there is benefits to it as well. If there's questions about an older year worth of samples, well, that year looked a little wonky for some reason, you've still got the samples there to go back and look at again.
Great, thanks.
Any other questions? All right. All right, I guess that's it. So thanks, Scott. That's good.
Welcome. Sorry, I was so short-winded.
Next week, Lise Koob will be talking about using otolith microchemistry to determine natal origin of black sea bass in the Gulf of Maine. So hope you can make it. We'll see you next week.